So this is the Leaving Cert Ordinary Level Paper 2 from 2015, and we're looking at question number 4. Part A says the diagram shows a parallelogram with one side produced. So here's the parallelogram, one side here produced or extended. Use the data on the diagram to find the value of x, of y and of z. So we have three angles here marked x, y, z. Give a reason for each case, or give a reason for your answer in each case. Okay, so, well, if this is a parallelogram, we know that the opposite sides are parallel, so that's parallel. We also have this side here parallel to this side here. And we do have some facts about angles in parallel lines, okay? So, one of the things we know is that if you have two parallel lines, this one, and a transversal, you can see this kind of Z shape here. When you have that situation, you can say that the angles enclosed by the Z are the same angle. So in other words, this X angle here will equal to this angle up here, which is 30 degrees. So we call those angles there, this one and this one, alternate angles. So the reason is that alternate angles are equal. Alternate angles are equal. Okay, so then we have we're looking for the angle y. Well, the angle y is inside a triangle. So we know that the three angles in a triangle add up to 180. So we have the angle 110 plus the angle 30 here, plus the angle y. We know that they add up to 180 degrees, three angles in a triangle. So we can find the missing angle here. Well, 110 and 30, that's 140. Plus the angle y is equal to 180. So the angle y must be 40 degrees. So 40 degrees, and the reason is that the angle sum in a triangle add to 180. In a triangle is 180 degrees, so that's our reason. Okay, and finally we're looking for the angle z with the reason. So the angle z here now. In a parallelogram, we know that opposite angles are equal to each other. So this angle here and this angle here will be equal. So if this is 110, then this angle here is also 110. And then we can say that these two angles here are on a straight line, which means that they add to 180. So this z angle here must be 180 minus the 110, which is 70. So the z is equal to 70. Degrees, the reason. Opposite angles equal in a parallelogram. That's the first part of the reasoning. And also that angles on a straight line add to 180 on a straight line add to 180 degrees. So there's actually two reasons for this. Okay, part B, the area of the parallelogram ABCD, that's over here, is 480 meters squared. Find the area of the triangle ABD. So we're looking for the area of the triangle AB to D, so this triangle. Well, the diagonal of a parallelogram splits the parallelogram into two equal parts in terms of area. So if this is 480 meters squared, the triangle ABD will be half of that. So half of 480 is 240 meters squared. Okay, so then it says E is the midpoint of CD, the line segment CD. So here we have E. Find the area of the triangle BCE. So this time we're looking for the area of the triangle BCE. So that's from B to C to E and then back again. So this blue triangle here. Well, that blue triangle will actually be half the area of the triangle BDC, because the E is the midpoint of the line CD, so it's going to split that triangle into two equal areas also. So it's going to be half of 240 meters squared, which is 120 meters squared. And that's the end of question number 4.